Hi, hello, my name is Muhammad Nadim from Mechanical Engineering. My CEP topic on AI for Smart Material Property Prediction subject Artificial Intelligence in Mechanical Engineering. AI for Smart Material Property Prediction revolutionizing materials discovery. An overview of how artificial intelligence is transforming materials discovery, speeding prediction, guiding experiments, and unlocking novel materials for real world applications. New materials challenge complexity beyond human reach scale of the problem. Millions of possible compositions and microstructures create a combinatorial explosion that experimental workflows cannot be covered. Cost and time predicting properties like elastic constants or thermal conductivity traditionally needs weeks of synthesis or heavy simulations, hidden correlations. Human intuition misses subtle high-dimensional relationships between composition, processing, and properties. Enter AI accelerating materials science, machine learning, and data-driven techniques learn complex structure property mappings from large datasets. AI models surface new descriptors, predict properties instantly, and prioritize promising candidates for experiments. Leverages databases, DFT, experimental, and literature. Enables high throughput virtual screening reduces time to discovery from years to months or weeks. Breakthrough predicting thermal properties 1000x faster. MIT's virtual node graph neural network VGNN predicts phonon dispersion and thermal conductivity orders of magnitude faster than brute force simulations. This speed enables iterative design of materials for thermal management in electronics and power systems. Why it matters faster predictions let engineers evaluate hundreds of candidates before a single synthesis, reducing waste and accelerating optimization. Applications heat sinks, thermoelectrics, high power electronics, and energy efficient devices. AI driven polymer discovery from algorithms to lab success. AI models at Georgia Tech predict polymer properties from sequence and formulation gilding synthesis choices for energy storage, filtration, and recyclable plastics validation in lab shows AI suggested polymers meeting or exceeding targets, shortening the design loop. Large language models LLMS in materials prediction. LLMS such as Ella bot combine language understanding with materials data to predict tensors, elastic constants, bulk modulus, and other properties with improved accuracy. They relate narrative experimental nodes to structured data, enabling intuitive inverse design prompts. 33% lower error on elastic constants versus prior models. Supports natural language queries for property targets, bridges literature, and databases for richer feature sets. MP Predictor AI-powered web tool for 41 material properties. MP Predictor accepts chemical composition and returns predictions for 41 properties using cross-property transfer learning. This lowers barriers for researchers and industry, making advanced prediction accessible without deep ML expertise. Accessible, web-based, no local compute required. Cross-property learning improves accuracy for low data properties by sharing knowledge. Actionable provides ranked candidates for experimental validation. India's opportunity AI and materials innovation ecosystem. India can leverage growing AI talent and strong materials research centers to leapfrog traditional and R&D priorities include electronics, energy storage, aerospace alloys, and sustainable materials for circular economy. Electronics, thermal management, and novel semiconductors for domestic manufacturing. Energy AI-guided materials for batteries and capacitors to speed adoption. Sustainability, design recyclable polymers and low impact materials at scale. Challenges and future directions. Data quality, representativeness, diverse standardized datasets remains scarce. Experimental closure, linking predictions to scalable synthesis and manufacturing. Model transparency, interpretable AI to build trust in high stakes domains, ethics, and IP. Responsible sharing, provenance, and fair access to AI tools. Conclusion: AI is the catalyst for next generation materials. AI shifts materials science from trial and error to predictive, targeted design, faster, cheaper, and more precise call to action. Adapt AI tools, invest in curated data, and build cross disciplinary teams to secure India's leadership in advanced materials. Invest in data, accurate, high quality, experimental, and computational datasets. integrate lab and AI, close the loop between prediction and scalable synthesis, collaborate, form partnerships across academic, industry, and government. Thank you.